Hi everyone, let's go ahead and get started with the Numpy introduction. We are going to see here array creation, indexing and slicing. Thereafter we will see about the data types, arithmetic operations, array generation and array reshaping. And these are the data types available in Numpy. We have an integer, boolean, unsigned integer, float, complex float, time delta, date time object, string, Unicode string and fixed chunk of the memory. So these are the data types. Some of these data types we will be evaluating in this lecture. You can install Numpy by typing pip install Numpy, but if you are using Anaconda, so this pip install Numpy automatically comes there. I mean to say that you don't need to do this because Numpy automatically comes as installed in Anaconda. Let's go ahead and create your array. So you can simply do like this: a equal to np dot array, but before that you need to import Numpy. So you can write here import Numpy as np. So with this you import Numpy as shorthand notation as np. Thereafter you write here a equal to np dot array. Inside this you can pass a list. If you remember, we already have a list which was earlier known as variable 1 perhaps. Yeah, so this was the list there. You can simply pass this list inside this array. So this list will get converted as the Numpy array. Now if you see there, the a becomes a Numpy array, and if you check the type of this a, it is the Numpy array, nd array there. Other than that, you can check the shape of array. You can simply write here a dot shape. Here it says that the shape of this array is 9. That means there are total 9 values inside the variable 1. You can check that with the length there, something like this. Alright, thereafter you can simply print your array A. If you print your array A, you see there the data type of this array A is there unsigned. This array A is actually Unicode string. U means Unicode string there. Alright, perfect. And this 32 says that a 32-bit is used to represent this Unicode string there. Let's go ahead and see how you can create the two-dimensional Numpy array. So two-dimensional Numpy array is actually list of the one-dimensional array. That means if I say here where 2d is equal to, you can say that the variable 1 and the variable 1. So this is going to be the list of list of the one-dimensional array. Alright, so the one-dimensional array, list of one-dimensional array is actually the two-dimensional array. That means you can write here, let's say b equal to np dot array, and inside that you pass their variable 2d. If you do something like that and if you print your b, now you will be getting here two-dimensional array, and you can simply just copy this whole thing from there. You can paste it here. You can write it type of b and then b and shape and length of here variable 2d, and then see what happens here. You get there Numpy nd array and the shape is 2 cross 9. That means there are 2 rows, 1 and 2, and there are total 9 values, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So you see there earlier we had only 9 values there, but now we are having 9 values in each of these rows there. And the length of this array is saying 2, because if you apply their length on multidimensional array, it shows you only the number of rows there. Alright, so on the 0 axis, the 0 axis is now number of rows and axis 1 is the number of columns. That is why it is saying that there is the length which is 2 there. Let's see how you can do the indexing in your Numpy. For example, if you want to access any of these array, any of these values inside this array, or you can say that in between these, these between values in this array, how would you access that? It is very much simple, like list. You can access this. For array A, when it is one dimensional array, then you just need a single slicing index. So this starts with the 0 till the length -1, that means 0 to 8 there. So if you write there 0, you will be getting the first value. If you write there 8, you will be getting the last value. And at the same time, if you write here -1, so it doesn't matter how long your array, it will always give you the last value, something like this. But if you write there the -2, it will give you the second last value. That means if you provide there minus, so it just reverses the order, and 1 says that this one, but in forward mode, the first index means the 0. Alright, that means here in the array A. But how do you access the two-dimensional array in NumPy? If for a two-dimensional array, you need there two indices there. For example, in this, if I want to access this one, and if you write a simple term something like this, you won't be able to access this. In fact, you will be getting the whole row, something like this. If I say B0, that's the B array. So the B0 says that the first row, it's going to give you the first row. Alright, but if I want this one, and then for that you need to provide there the B0 of 0. Since you provided the B0, it becomes their one-dimensional array. Now you can access this value in one-dimensional array by providing there the first index, which is a 0 there. Now you would be able to get this 2 there. And if you have something index something like this, you can simply put here 0 cross 0. So this also denotes the same thing what you can get with this particular thing. Alright, let's go ahead and see how you can create and these array which have just integer values, and then we can apply there some statistical operations there. For example, if I write here A equal to an array np dot array. And if you remember earlier, we used to provide here a variable inside this, but you can provide a direct list there. I'm just gonna give here some, the random values there. Alright, so for these random values, now I see there the array A. In this array A, now you can provide statistical operations. You can do the statistical operations, something like this: A dot mean, A dot variance, A dot standard deviation, and alright, if you just run it, it says that the mean of these values are 29 and variance of these values is 707 and standard deviation is 26. The same thing you can achieve if you write there the np dot mean and you provide your array. So the same thing you can do with this np dot variance and you provide there A. So the same result you would be able to get that. You can also provide there np dot median and you can provide your variables there. So you are getting here median as 32, but the mean is 29. So what happens here in the case of the median, if these numbers are, the length is odd number, then the middle value is chosen. It do here the sorting, and then middle value is chosen as the median. So we have here median is 32, which is actually middle value. If we just sort it, so we will be getting here a 1, 2, 5, 32, 32, 56 and 75. So in median, this 32 will fall there, alright, as the middle value. Alright, so this is all about in this lesson. I'll see you in next one.